Thank you, everyone, for joining us to the session today. This is Claudio Novi's topic, tracking, and the topic that we are covering today can be simple for some persons, and also can be a little complex if you are not familiar with the architecture patterns for monolith and microservice as well. But also, this topic looks simple, but brings a lot of complexity as well. So today, we're going to talk about the journey from monolith applications to microservice in a visual way for beginners, right? So just a quick introduction about me. I'm Pedro. I'm a solutions architect at AWS. I work at AWS over 3 years and a half. And just a curious fact about me, I practice skateboard and also I play electric guitar. So at AWS, as a solution architect, I work for software companies, helping them on modernization journey and also orchestrating their microservice and applications with Kubernetes. So here with me is my colleague Henrique. Henrique, please introduce yourself.
Yeah, hello everyone. My name is Henrique Santana. I'm Principal Cloud Support Engineer at AWS. I work for AWS about 6 years, helping customers that are running container workload at AWS, mainly for ECS and EKS for gates as well. And I'm also chapter owner for Dublin side. I live in Dublin abroad. I'm Brazilian, but I live in Dublin for 6 years, at the same time that I'm working at AWS. A curious fact about myself is I dived into the Irish and Finnish seas. And one thing that I could say is that the water is very, very cold. The agenda here for today is some basic things to start, like what is the concept about monolith and microservices as well, and when monolith makes sense, and yes, it makes sense for some use case, and of course, challenge with it. And after that, we will move to a real-world scenario where you explain how to break this into microservices, and also when you should transform your application. And of course, common challenge to do that and running microservices with your workload, and some takeaways as well. So what is monolith architecture? One thing that you should think about is one application, a single application, a key piece of the application that has all the components together. One analogy that you think is like a building, with a lot of apartments. You can think the apartment as the component here, and the building as the application itself, the set of everything together. So with the apartments, you can think about some pros and cons to have an apartment on the building, right? So you can have, for example, the apartment that you easily can go for the neighbor and knock the door and ask for sugar or ask for join a barbecue party or something like that. However, there are some downsides as well. If you are, for example, moving, get some neighbor that is moving, changing and doing noise on a late night, or a baby crying, and your sleep time as well could be affected by that. So similarly, the monolith application will have these pros and cons. We will talk about this when you get there. Talk about the microservices now, and they are it's a bit different. They are smaller, however, specialized applications that working together to deliver the whole application. On this image, you can see the microservice, and each microservice will have their own database. Moving to the analogy here is a bit different. We have a campus here with different buildings, multiple buildings. And in this case, for example, we have the green building, which represents, let's say, the administrative building, and the red building, which let's say this is a library. So for the apartment, you need to knock the door, you open your door, knock the neighbor door. It's very easy to communicate, right? This is the monolith application. For microservices, if the green microservice, which is the administrative building, need to, for example, borrow the book, they need to walk through all the path, which is the API call for microservice, to talk with that microservice, to borrow the book in this case, on this analogy here. However, there are some benefits. For example, if you, let's say that the red microservice is out of their service, that is doing a maintenance or something like that, they are not unable to borrow the book. So the administrative, the green one, we still need to walk through all the path to get there, knock the door. However, there is no book to borrow. No problem. The administrative building is still working. They are not directly affected. You're not unable to borrow the book at that time. But still, they can do everything else that they are like they need to do, like the administrative things that they need to do. Okay, when a monolith makes sense. So basically, if you think about a small startup that is just creating or starting the company, they usually have a small developer team, like 5, maximum, usually 2 developers. And Monolith would make sense for them to go fast to the market and deploy this very, very fast. Well, it's very easy to develop because you have a single component, which is a single code base. So it's a single repository where they work together. And it's a single language as well, since it's the single code base. It's only a specific language that you decide, the developer will decide. Different from the microservice that they could have multiple languages like Python, Node.js, and using different microservices with different language. It's possible and increase the complexity. It's also a single pipeline. So since you have a single code base, also you have a single pipeline to deploy your application. So all these would bring a lower operational complexity. I'm not talking about developer complexity here, because we see that with the application grows, it starts to get more complex to handle with the code base. I'm talking about the operational complexity here. Since you have a single code base, single pipeline, and so it's easy to maintain this and keep track of everything that we're doing. And also, like the example of the knocking the door of your neighbor or walking through the path on the campus thing, the performance is better than comparing with microservices, because instead of doing an API call, external call going through the network, you talk as function or method inside of your same application. So the performance comparing this is very fast. The other thing is to debug and trace issues. For debug and trace issues on Monolith, you have a single thing you can easily trace the bugs that you are tracking. For microservices, since you have multiple servers to debug, and most of the time you don't know exactly when the bug is starting or the issue is starting, it's very complex to trace this. We have observability to get there, but comparing with Monolith is much easier. However, it's not everything that like a dream. So if it would be like that, everyone will be using Monolith. But it's not the case for us when you start to grow. For example, we have here a single developer that is handled with the code base for the Monolith application, and they have a new feature to deploy, right? So they start to deploy these and package these and move to production. And however, there are more, the company is growing. So at some point, this application starts to grow, more features, and of course, more developers to deliver the feature at the pace that the company is looking for. And you start to having like 2, 3, 4 developers, and the code base keep growing and growing. At some point, to manage that is very challenging. So this brings some challenges that we have with Monolith. So for example, one thing that I mentioned about the library not working and the administrative building still works, for Monolith is not true. If a single component of the application goes down, the whole application will go down as well. And of course, if you are like the apartment thing, if you are doing changing or maintenance or anything would affect the order. So if you are having this single code base and you have a new feature to deploy, likely that you need to change not only the code base or the part of you are looking for to change, but you need probably to change in different parts of the application. And these start to be very challenging and complex as well with the time that you are growing your application. And talk about the grow application, it's impossible. Like the microservices, you have your microservices, you can grow, and at some point you can break these in multiple microservices. For Monolith, since it's a single application, if you are growing, the whole Monolith application will grow, and at some point, it's very challenging with multiple team members, multiple developers as well. So moving now to real-world scenario. Pedro, can you bring us a real-world scenario example and how we can break a Monolith application into microservices, and this will help them?
Sure. Thanks, Henrique. So let's imagine right now that we have a real-world scenario here with our Monolith application, and our Monolith application is a retail store application. So we are in November, we are close to the Black Friday season, right? So let's imagine that we are at the Black Friday season here. We also prepare our capacity for our environment with scaling many instances to support the requests during the Black Friday. But customers, keep in mind the common challenge from monolith applications, from monolith architectures that Henrique mentioned before. So imagine that customers or users starting to access our application, right? So we have many different customers. We have also a marketing campaign to sell some products, specific products, into our platform. And customers start an access from different locations, for different parts. And let's imagine that customers are doing checkout of the most requests at the same time. So with that, customers starting requests more and more, and everything is running at the same place. So with that, our application is growing, and it can fail down. So to solve that, your manager, the boss of the company, of our startup, asks us to move into microservice. But okay, I have these requirements to move into microservice, but how I can start moving to microservice? So the first thing, before we get hands dirty on that, to starting code and etc., we need to make the decision. So to help us to make the decision before starting code anything or moving any part of our monolith application, we need to use some methodologies to help us to drive that. So the first thing that we can use is domain-driven design. Domain-driven design, in other words, can be the bridge between the technical and the business team to align and define the domains and the boundaries within your application. So it helps you to define and align in a business and technical perspective, which makes sense to divide into microservice. So the other thing, more technical perspective, we can bring here the stronger figure pattern. That, of course, we have many other patterns to modernize applications, but stronger fig pattern is one of the most famous one. So basically, we're gonna dive deeper a little bit on that, how it works. But we have a proxy here at the front of monolith application that will handle the most of requests at the beginning. But after that, when we start moving into microservice, we have the proxy redirecting the connections or the traffic to the microservice. So, all right, once you have making the decision, now we need to discover our boundaries. How I can define my boundaries inside my monolith application. So let's imagine that we have a retail, right, application. So we have UI component, you have orders, we have a checkout, we have cart, and also catalog. But with those applications that or those boundaries that we discover within our monolith application, we need to start thinking about how we can connect each other to communicate the application in our environment. And the other portion, the other layer that you need to start thinking about is the data access layer. So here we can use SQL or NoSQL database, or also a cache database for each purpose, for their needs, for each application that we are building, or each boundary that we are building. Keep that in mind, that we need to align the needs with the business team. So once you make the decision, we define the boundaries, we know what we need to separate now. Let's start and isolate our apartments, right? Doing some analogies here. So now we have our retail store app and the logical division for each domain that we have defined. So let's start in with our customers requesting some information or access our app. We have the proxy. So proxy here, when you're talking about triangle figure partner, can be a load balancer or can be an API gateway to hold those requests, to proxy those requests for our main app. So the first thing, we have the proxy redirecting requests to the monolith application, and also we start and apply the struggle part that will be separating each domain, each boundary that we have defined before. So we started with UI, and the other portion of the domains that are running yet on the monolith application, we start moving into microservice. And once we don't need to do it at once, we just need to do it at one at a time. So once you complete all this movement here, we can, and of course, the data access layer to communicate it with each microservice to have their own database, their own data access layer. We can remove our proxy and redirect customers to direct access our monolith, our microservice architecture. And also, each microservice can communicate to each other through the network partners. Okay, so we understood now how to move into microservice, but what about the best practices with that? So there are 2 steps to drive success on this. So who knows or have heard about the 12-factor app before? Okay, just some people. Basically, 12-factor app is an open source methodology to help drive software development, software as a service in a declarative way. 12-factor app help us to move into microservice or cloud-native applications using the best practices in a declarative format to move and don't have the dependencies of each application, and also to scale and use the best, using the best practice for consuming resources on cloud. So if you are interested to help to contribute for this project is open source as well, so you can find on a GitHub and contribute to this as well. So, of course, as Henrique said before, we have some common challenge for monolith architecture, and also we have common challenge for microservice. So the first common challenge that to face it with microservice architecture is the communication, because we are moving from function or method calling from the monolith architecture to microservice architecture, starting with networking communication. So we need to be careful with that regarding security, latency, and so on. So the second one is observability. So before we had only one application, one instrumentation for all the modules that we have inside this application. And now we have many different applications, many different microservices. So now we need to instrument each application and have the 3 main pillars for each one: trace, metrics, and logs for each one. The third one is deployment and orchestration. So when we talk about monolith application, we have a single pipeline to that. Many developers access this pipeline, implementing new features, new releases for this application, and also orchestrate to one virtual machines can be a good thing, can be easily, but when you start in growing up, we need another kind of orchestrating. Of course, if you containerize these kind of applications, we also need an orchestration as with Kubernetes, for example. So into microservice, we have many different pipelines for each application, and now we can have one orchestrator to help us on that. And finally, we have a partial failure. It's regarding the resilience patterns at the application layer. So here, we're going to implement the retry, the exponential backoffs, the circuit breakers, and other resilience patterns at the application level. You need to be careful with the communication, and if one application goes down, we can avoid the waterfall failures. So just some key takeaways to keep in mind if you are moving from monolithic architecture into microservice. So the key takeaways is if you are a startup company or if you are trying to prove MVP service or a product, you start with monolith applications can be a good start. Don't bring at the beginning a complexity of microservice architecture. So the second one is microservice architecture helps you to solve specific growing pains. So if you face with the challenge that Henrique showed us before, like my company starting hiring more developers start implementing more features, I need to separate that, and also I have issues regarding the scalability of my applications. I'm looking forward to use Kubernetes to orchestrate all my environments, have more resilience on that. So microservice can be a good thing for you. So the third one, as I mentioned before, transform one step at a time, not all at once. Because if you try everything to move into microservice at once, it can be a huge challenge and a huge overwhelmed to become more resilience or security in terms of microservice architecture. And also, when you complete this topic here, the last one is more easily to achieve, because we now have these boundaries defined, and also the communication between technical and business team can be easier, can be in a clear way to define different parts of my application that is in monolith architecture. So thank you so much. This is our talk. We are open to questions. Please provide your feedback. It's really important for us to improve for the next ones. And also, if you would like to reach us out at the LinkedIn to talk a little bit more about the topic, feel free to contact us. Thank you so much, everyone.
Thank you. Yeah, can you go for the microphone here? Pedro, there is one here. Yeah.
Thank you. So, in this microservice architecture, let's say we had a monolith application, and earlier it was a simple inner join between two tables, right? You build that application working fine. We are moving to a microservice architecture now. This inner join was working fine in monolith. In microservices, this inner join will be converted into a get call, or it has to be a asynchronous call. How do you decide it is a get call? Like for example, order and order confirmation email, right? So when a member or a customer places an order, order is placed, you want to send a confirmation email. In the confirmation email, you are showing the product information too. So it's a join between order and item, right? Now, item is a separate service, order is a separate service in the microservice world. How do I pull my item information? That's the question I'm asking. Is it a get, or is it a asynchronous call to the item service, and item service responds back to me in a queue, and that queue's response I use to send the message to the customer, right? So I want some design principles here. When do you, probably both are possible. Get is also possible and asynchronous is also possible. How do you decide I'm going to use get, or I'm going to use a messaging system and I'm going to make it event-driven?
All right. So good question. Regarding the asynchronous or synchronous requests into microservice architecture, it will be decided, I would say, at mainly to the business level. For example, at the payments level, we need don't need it asynchronous. For example, you need to wait for the payment concrete at the API, to the gateway, the payment gateway, for example, and I would say that is more defining at the business level. But for example, depends of your business needs. You can have both parts at your application. For example, if you have, like I said before, the payments can be synchronous and also the orders can be asynchronous. I will give you a real use case, for example, for at Amazon.com. At Amazon.com, for example, if you buy something at the retail store online, we don't know if you have the product at the store. So basically, the request will be handled asynchronous, and we'll send to different queues for each department, for the delivery, for the warehouse, for the payment. So each part of business units behind the scenes will work to close and confirm your buy at your purchase at the website. So it depends of your needs that you are looking for, but I would say try to align with the business team to define the domains as much as possible.
Thanks so much for the presentation, guys. So I had a question in thinking about when I want to translate my monolith to microservices. Does it always make sense to kind of break it up into separate code bases and separate microservices, or is there a use case where, hey, you know what, it still might make sense to keep everything in one code base but separate it into a number of deployable different services that I deploy? Conversely, is there a scenario where I still want to keep my monolith, but I want to break it up into different repositories with kind of like better interfaces, but that can kind of solve the multiple people kind of shipping features together? So I guess I'm just trying to think, does it always make sense to have like clear-cut separate code bases and separate services, or is there like an in-between?
Yeah, the mono repo question is basically what you're looking for, right? See if you can use a mono repo with all the code base, and then there are a lot of blog posts and articles about that, and there are different opinions. The polling thing. So I will not answer this question exactly. We have a lot of links, by the way, the presentation. You can check after this slide. There are links. Can you pass this slide? Yeah, there are some reference, and I put more reference there as well to elaborate more on that. But basically, it would depend on the use case. So the question about if you, for example, you talk about to have the monolith on a different repository, I'll challenge if this would be feasible to do. So I'm not sure about that. I don't think so. But maybe you have a specific use case that would different components. But it likely will be very messy to do that, because like I said, if you are changing code here, likely you need to change different parts of the code, even that you are not only of this code part. You would need likely to change also different place to build the final, like the WAR file, if a Java application or whatever. You need to have all this change to get on that same repository to deploy at the end. And also, if you start to have this, you start to create complexity of your monolith, because you have multiple pipelines as well to handle this, to deploy, and you need to sync these deployments to not overwritten them. So it's a bit complex. I hope we answered the question.
Yeah.
Thanks so much.
Always keep in mind that if you separate more, like as we mentioned here, monolith to microservice, but you can like microservice or micro or micro nano service, for example. it can be, as Henrique said, can bring a lot of complexity. So that's why defining with business team will avoid you to break in a multiple granular way your applications, and you need to operate operational overhead for your environment, right? So keep that in mind when you starting to separate these applications.
Thank you so much.
You're welcome.
You are out of the time. Yeah, hold on. Yeah. Okay. We can take offline.
You can ask us, no problem.
Okay. Thanks.
Thank you.